Okay, let's start the 10-4-10-5 quiz review. Remember, the quiz is tomorrow. So let's take a look at these problems on the review. First question asks you, what is the measure of the central angle for a polygon with 18 sides? You would take 360 divided by 18, and that would give you 20 degrees. Second one, if a polygon has a central angle of 12 degrees, how many sides does it have? Again, you have 360 divided by the number of sides equals the angle measure, which is 12. So when you set that up and you cross multiply, you're going to get, again, 360 divided by 12 is equal to 30 sides. Number 3, the similarity ratio of two similar triangles is 5:4. So the perimeter ratio is 5 to 14, also written as 5 to 14. The area ratio will be 25 to 196, also written as 25 over 196. Number 4 says the similarity ratio of two similar parallelograms is 4:5. The area of the smaller polygon is 30 centimeters squared. What is the area of the larger? So the similarity ratio is 4:5, but we're talking about finding the area of the larger, so we have to square both numerator and denominator, and then set that equal to the equation which has the area of the smaller in the numerator and the larger in the denominator. So this becomes 16 over 25 is equal to 30 over x. So you'll get 16x is equal to 750. So x, the area, would be equal to 46.875. Number 5 then says you have two similar rectangles, and they have areas of 32 inches squared and 50 inches squared. So you know that 32 is to 50 as a squared is to b squared. I'm going to take the square root of each of those. So that means a is to b as the square root of 32. That's 2 times 16. So that becomes 4 root 2. And b, 25 times 2, or 5 root 2. The root 2's cancel. So the similarity ratio a to b is 4 to 5. Next, you are given a question that asks you to find the area of a decagon with a radius of 9. So draw in those 2 radii. So you have a radii of 9. Then you'll need to find this central angle measure. By dividing 360 by the number of sides. It's a decagon, so it has 10 sides. That means the central angle measure is 36 degrees. Remember that the apothem bisects both the side and the angle. So I'm looking at a triangle with a central angle measure of 18 degrees, a radius of 9. I need the apothem and I need the length of the side. So for these I'm going to use sine and cosine and tangent, the trig ratios. For finding the apothem, I'll use cosine of 18 is equal to a over 9. Multiply both sides by 9. You have 9 times cosine of 18 equals a. So a, the apothem, is equal to 8.6. Then to find the length of the side, you're going to use sine. So sine of 18 is equal to x over 9. Again, multiply by 9. So you have 9 times sine of 18 equals x. So x is equal to 2.78. Remember, that is only half the length of the side, so you have to double that so that the length of a side is equal to 5.6. Then the area is equal to 1/2 the apothem, 8.6, times the perimeter. The perimeter is a side length, 5.6, times the number of sides, which is 10. And that should give us an area of 240.8 centimeters squared. Okay. Next, number 7. This one is very similar. You're going to use the same formula, it's just you're given different information. Instead of finding the area, you're going to actually find the apothem. So you're going to use the formula. It says find the length of the apothem of a dodecagon with an area of 720 inches and a perimeter of 120. The formula is area is equal to 1/2 the apothem times the perimeter. Now substitute in the values you have. The area is 720. That's 1/2 times then the apothem times the perimeter. Combine like terms on the right-hand side, you're going to get 720 is equal to 60 times A, because when you multiply 1/2 by 120, you're going to get 60. Divide both sides by 60, and you'll get that the apothem is 12 inches long. Number 8 says find the radius, the length of the apothem, and the area of the regular hexagon with a side length of 20. And if you have a hexagon, you can use either the special right triangles or you can use the trig ratios. Okay, if the side length is 20 because it's a hexagon, this is an equilateral triangle, which means the radius will also be 20. Remember, the apothem bisects the angle, bisects the side. So actually, you could even use the Pythagorean theorem here. The length of half the side is 10, the radius is 20, and you want the apothem. So if you use that this is a 30, 60, 90, you'll find that the apothem is equal to 10√3. If you use a trig ratio, you could use, sine of 60 is equal to A over 20. So you'll get that the apothem in that case is equal to 17.3. And then again, you could use the Pythagorean theorem, a squared plus 10 squared equals 20 squared. All of those will give you the same length for the apothem. This would just look like 10√3, and that's approximately equal to 17.3, which you got using the trig ratio or the Pythagorean theorem. So then the area of this hexagon is 1/2 the apothem, 17.3, times the perimeter, which is 6 times 20. Number of sides times the length of a side. So the area will be 1,038 feet squared. Number 9 asks you to find the length of the adjacent side of a triangle with an area of 1,278.7 feet squared, a side length of 50, and an included angle of 43. So you want to draw that picture. You know that it has an included angle of 43 degrees. One of the sides is 50, the other is x. The area is given. Remember, the formula is area is equal to 1/2 b times C times sine of A. The area was 1,278.7. That's equal to 1/2 of 50 times x times sine of A. So take those values, the 1/2, the 50, and the sine of A, and put that in your calculator. You're going to get 1,278.7 is equal to about 17x when you combine the 1/2, the 50, and the sine of A. And then when you solve that by dividing both sides by 17, you should get that that is about 75.2 feet will be the length of that adjacent side. Number 10, the similarity ratio of two pentagons is 2 to 9. Then you are given the area of the smaller triangle. Remember, you're talking about area, so you want to square that similarity ratio, is 24, and you need to find the area of that larger pentagon. So this becomes 4 is to 81 as 24 is to x. So 4x is equal to 1944. You divide that out, you're going to get the area is 486 feet squared for that larger triangle. Next, you're asked to find the area of a decagon. Again, a decagon has 10 sides, and it has a side length of 12. I'm not going to try to draw a decagon by hand. I'm just going to draw a triangle that represents one of the central angles. The side length is 12. My central angle measure will be 360 divided by 10, which is 36 degrees. When I take 36 and divide that by 2, I get 18. So now when I have half of that triangle formed by two radii, this angle is 18. The side length is 6, and I need the apothem in order to find the area. So I will use a trig ratio here, tangent. So tangent of 18 equals 6 over A. I'll multiply both sides by A, so A times tangent of 18 equals 6. Then divide both sides by tangent of 18. So A, the apothem, is equal to 18.5. Then I'll find the area. Area, remember, is equal to 1/2 the apothem times the perimeter. So 1/2 of 18.5 times, it's a decagon, so that's 10 sides. Each side is 12 inches long. When you calculate that out, you should get approximately 1,110 inches squared. Number 12 says find the area of a regular octagon with an apothem of 32. So if you have an octagon, you know that the central angle is 360 divided by 8, which is 45. Then the apothem bisects that angle, making this half of the triangle have a vertex angle of 22.5, an apothem of 32, and we need the side length x. So I'm going to use tangent for this. Tangent of 22.5 is equal to x over 32. Multiply both sides by 32. I get 32 times tangent of 22.5 equals x. And that gives me x is equal to 13.3. Now remember, x is only half the length of this side, So you have to double it in order to get that whole length. So the side is 26.6. So then to find the area, I will use area is equal to 1/2 the apothem, which we know is 32, times the perimeter. So that's the length of a side, 26.6, times the number of sides, which is 8. When you calculate that, you're going to get 1,702.4 millimeters squared. Okay, 13 says two similar pentagons have area of 75 centimeters and 192 centimeters. What's the similarity ratio? Now you're given the areas, so you have to work backwards. You have 75 is to 192 as a squared is to b squared. You want to take the square root of each of those. Square root of 75 becomes 5 root 3. Square root of 192 becomes 8 root 3. Square root of a squared is a. Square root of b squared is b. Root 3 over root 3 cancels. So the similarity ratio a to b is 5 to 8. Okay, next, a regular polygon has 20 sides. Each side is 18 inches long. What is the length of the apothem, the length of the radius, and the area of the polygon? So now I have a regular polygon. It has 20 sides. I'm just going to draw that triangle formed by 2 radii. So 360 divided by 20 gives me a central angle measure of 18 degrees. Remember that the apothem bisects that angle and bisects the side, so 18 divided by 2 gives me an angle measure of 9. Here's the triangle with that vertex angle is 9 degrees. The length of each side is 18. That makes half of that a 9. You need to find the apothem and you need to find the radius. So to find the apothem, I will use tangent of 9 is equal to 9 over a. So a times tangent of 9 equals 9. So a is equal to 9 divided by tangent of 9. That's going to give me an apothem of 56.8. Then to find the radius, I'll use sine. So sine of 9 is equal to 9 over r. So r times sine of 9 is equal to 9. So then r is equal to 9 divided by sine of 9. The radius is then equal to 57.5. Then you have to find the area of this polygon. Remember, the area is equal to 1/2 the apothem, which is 56.8, times the perimeter, which is 20, times the length of a side, which is 18. So that's going to give me an area of 10,224 inches squared. Number 15 says a realtor has a plot of land for sale. She knows the plot is 4 acres. It's actually a triangular plot. That should say that. It's a triangular plot. It's 4 acres. Each acre is 43,500. So the area of this plot is 174,000 feet squared. And what else does it say? Along one side, it extends along a road. So here's my road. And this side is 600 feet. A second side extends at a 74 degree angle, so that's x. So the formula or the equation is area is equal to 1/2 b times c times sine of a. You have the area, so you substitute that in. 174,000 is equal to 1/2. You have one of the side lengths, so you substitute that in. The other is what you're looking for, x. You have the included angle measure, sine of 74. And just like before, we took 1/2, we took the 600 and the sine of 74, put it in the calculator, and you should get 288.4x. When you solve that, you get that x is equal to 603.3, and that's the length of that second side. 2 more and we're done. Next says the figure shows a square inscribed inside an octagon. Find the area of the shaded region between the two polygons. So the first thing you need to do is find the area of the square and the area of the octagon. So here's the square. There's my apothem, A. When I draw that in, that makes this a 45, 45, 90 triangle. If the length of the radius, or the hypotenuse in this case, is 16, I remember the length of the leg is 1 and the hypotenuse is √2. So I have in my similar triangles, the length of the leg, A, is to 1, as 16 is to √2. Sorry, that's a 1, not an x. So now I can simplify this. It becomes the apothem, A, is equal to, I have to rationalize that denominator, 16 √2 over 2, which is 8 √2, is the length of my apothem. You could also use one of the trig ratios if you wanted. So now the area of the square is the length of a side. The apothem is half that length, so the length of a side, this whole side of the square, is 16 square root of 3, or 22.6. Let's put it in decimal form and make that 22.6. So the length of the side of the square is 22.6. So the area of the square is going to be 22.6 squared, which is about 510.76. Then you have to find the area of the octagon. Let's do that here. So in the octagon, I'm going to draw a couple other radii. I have this and this. I'm going to take 360 divided by 8, that gives me 45. I divide that in 2. 45 divided by 2, it's going to give me 22.5. So in this triangle, where the length of a side is, let's see, the radius is 16. I need the apothem. This angle measure will be 22.5. To find the apothem, I'll use cosine. So cosine of 22.5 is equal to A over 16. So A is equal to 14.8. So the apothem is 14.8. Now I also need the length of the side, so I'll use sine. So sine of 22.5 equals x over 16. That gives me x is equal to 6.1. Remember though, that's only half the length of a side, so I have to double it. Therefore, a side is equal to 12.2. So the area of the octagon is going to be equal to 1/2 the apothem. The apothem we said is 14.8 times the perimeter, which is 8 times the length of a side, 12.2. That will give me an area of 722.24. Now the shaded region between the two, when I look at the shaded region between those two figures, that's here and here and here and here, I can obtain that by taking the area of the octagon and subtracting the area of the square. So I'm going to have 722.24 minus 510.76 to give me a shaded region of 211.48. Now in the last problem, we have to cross out this x. You don't need that. You're asked to find the area of the triangle. That is, you have the lengths of two sides, and you have that included angle. Remember, this is a scaling triangle, so you don't have a right angle, so you have to find a different way to find that area. So it's the formula area is equal to 1/2 b times c times sine of a. So the area is equal to 1/2 21 times 53 times sine of 57. When you multiply all that out, you should get 466.72. If you're successful on this review worksheet, you should be successful on tomorrow's quiz. Remember, the review sheet, if it is completed, can be worth 2 points, 2 bonus points on your test, so please remember to bring it along tomorrow. Thank you and have a good evening.